This is the 3.3 Properties of Addition and Multiplication video. I'm actually going to be continuing, so finishing up example 2 and example 3, and then we have some key ideas with some new properties. Here's our key ideas, and just like in our notes from example 1, this is something you want to kind of be able to pull out. So put some stars around it or something that's going to help you see that very easily in your notes when you're reviewing and studying. All right, so our first key idea is about the addition property of 0. So what this addition property of 0 property means is that the sum of any number and 0 is that number. An example would look like this. So if I had 7 plus 0, it's going to equal 7. Algebraically, it could be a plus 0 is going to equal a. And if you look at it, my definition says the sum of any number, so in this case it's 7, and there's a keyword indicating addition, so the sum of any number and 0 is that number, is 7. Same thing with algebra, a plus 0 equals a. 7 plus 0 equals 7. The next property is the multiplication properties of 0 and 1. So it's a little bit different. The first part of this property is that the product of any number and 0 is 0. So anything multiplied by 0, well, is 0. The product of any number and 1 is that number. So this is both, actually all of these properties are things that you already know. It's just putting them into play. So my examples for you look like this. If I had 9 times 0, it would equal 0. So that's reinstating that the product of any number and 0 is 0. Algebraically, it would look like this. A times 0 equals 0. And then if we're talking about the second part of it, the product of any number and 1 is that number, it would just look like this. We could do 9 times 1 equals 9, or a times 1 equals a. Okay, so example 2 is using properties to write equivalent expressions. So this is exactly like what we learned on example 1, only we were dealing with the commutative and associative properties. Now we're going to deal with, we're going to add in there the multiplication property and things like that. So here we go. Here's part A. So the first step with this is to simplify the expression 9 times 0 times p. So our first step is to rewrite out the problem. So we have 9 times 0 times p. And then we have to figure out what are we going to do with it. So you learned just from talking about our multiplication property of 0 and 1 that any product of, or the product of any number and 0 is 0. So what we can do is we can start off by writing it as using the associative property and saying 9 times 0 times p and grouping that together. Don't forget a really important key factor here in writing this down, your step that you used. Why did I group it together? Because I know that the product of any number and 0 is 0. So that right away can help me solve that 9 times 0 is 0. And then I have 0, then I write the rest of what I have, 0 times p. And 0 times p, we should even know using it algebraically, it also equals 0. Because any number, or the product of any number and 0 is 0. So regardless of what p actually equals, it could be 6, it could be 24, it could be 19, it could be 1000. It doesn't matter what p equals, it's always going to equal 0. So that is my final answer. I use the associative property of multiplication, and then the last thing I used right here was the multiplication property. You can label it like this, of 0. And that's how you would complete a problem like that. The next I want to do is simplify the expression 4 5/10 times r times 1. So the first step we do is we rewrite our problem. So we have 4 and 5/10 times r times 1. Notice how I was really careful about how I put my decimal, and I made sure it was low, especially since I'm writing on an iPad right now. I could have really gone through that fast, and it could have not looked any different from each other, so be really careful of that. So I rewrite out what I have first. Then I'm going to use my associative property to do some grouping. So I'm going to leave it at 4 and 5/10 times r times 1, and I'm going to group something that I know I can solve. So I know right now, and there's a couple different ways you could do this, but what I'm going to do is I'm going to start with my r times my 1. That gives me, or I use that with the associative property. So now I have 4 and 5/10 times r times 1, but I want to do my r times 1 first. Don't forget that whatever I multiply, because my multiplication property of 1 tells me the product of any number and 1 is that number. That's why I chose the r, because it doesn't matter what r is. I could fill any number in for it and it would still equal 1. So r times 1 is always going to be r, whatever r equals. So I'm going to put my r down here, and then I'm going to multiply it by my 4 and 5/10. Okay, so in this case, I used the multiplication property of 1. You can abbreviate it like this. Okay, so because I said r times 1 is always r. It could be 37, it could be 17, it could be 30. No matter what I do, whatever I fill it in for, it's going to be that same number. It'll always be, 37, whatever numbers I pick, it'll always be that number. So now I'm left with 4 and 5/10 times r. If there's nothing else that I can do with it, it becomes 4 and 5/10 r, like that. And that is my final answer. Okay, I got a joke for you. Now this one's a lot funnier than the other one. I personally think this one is actually funny. Read it, kind of laughed out loud. All right, so here we go. So I'm gonna write it out, and then I'm gonna draw my picture. Why do birds fly south for the winter? Are you ready? Because it's easier than walking. You get it? Isn't that funny? Like this walking thing is for the birds. So that's why they fly instead of, okay. All right, well, good joke. Moving on. All right, now that you're done laughing, the example 4 is the real life application. Okay, so if you want to kind of follow along in your book, it's on page 129. And that was a total misprint. It is not example 4, it's example 3. All right, so it says you and 6 friends play on a basketball team. A sponsor paid $100 for the league fee, X dollars for each player's t-shirt, and $68.25 for the trophies. Write an expression for the total amount the sponsor paid. So basically, this is a team that gets a sponsorship. So the sponsor usually pays for the team to play, so the parents wouldn't have to pay for their kid to play. So it's talking about $100 for the league fee, X dollars for the players' t-shirts, and $68.25 for trophies. Write an expression for the total amount. So a couple of keywords in here. We've got the word total. Let's see here. $68 for the trophy. But the total is what's telling us that we're going to be using which operation. And that's what I want you to think about using your table from 3.2. So obviously we're going to be using addition. That's what that's meaning. So now we need to put all this together. To start off, I'm going to start off with what they tell us. So we've got $100. That's what the league sponsor, or that's what the sponsor is going to pay for our league fee. Then, here's the tricky part. They don't put it in actual words, or in numbers. They put it in words. We've got 6 friends. But a common error in this is that you forget about you. There's you and 6 friends playing the basketball team. So how many total people are playing on this team? 7. So you and 6 friends you plus the sixth person is 7. Play in a basketball team, and you pay $100 for the league fee, X dollars for t-shirts. So that's why it's 7 times X. We get our X dollars because we don't know how much the t-shirts are. And $68.25 for the trophies. So now we have a problem put together and we need to solve it as much as we can. If you're looking at this right now, you're seeing that you can't add 100 plus 7x, and you can't add 7x plus $68.25. So you have to do something where we have to put things together before we can solve anything. So we've got addition that we're working with. We could use our commutative property of addition, and we could move around things. We can change the order. So I'm going to change the order by taking and moving my 7x and adding 100. And so I flip-flopped my 100 and my 7x. And then I'm going to add that to the $68.25 that I didn't move. Doing that, I did the commutative property because I changed the order. Then I have to solve as much as I can. Can you add 100 plus $68.25? Sure, you can actually mentally do that one and get $168.25. Add it to the 7x that we originally had. Can you solve any further? No, we don't know how much the t-shirts are. Maybe in a real life situation, the team is all put together, everything's ready, but the t-shirt place hasn't given their total for each t-shirt. So yeah, you could actually, this does make sense. It's not like they're saying, oh, we're not going to tell you. It does make sense. It's just the fact that it's unknown right now. And that's what algebra and variables are all about. So this is as far as we can actually solve it. So the expression for the total amount is 7x plus $168.25. Alright, once you're done with your video and you've taken all the notes and you feel like you're understanding it pretty well, I would like you to do big green page 130, numbers 9 through 11. Then you have to do 15 through 25, and then finally 35 through 42. 35 through 42 are the fair game review, so they're all review questions from different chapters. You're doing all of these problems. You're not doing an even or an odd. You're doing all of them. So make sure that you don't say, oh, I didn't know that we had to do more, because you weren't listening to what I had said. So make sure all of these problems are completed for Wednesday. And then I also will check your additional work from that was due Tuesday on Thursday. Everything will be due Thursday.